Hello, welcome to lesson 105. It's called Recognizing and Extending Geometric Sequences. If you don't have a calculator, pause the video and go get one. You will not want to do this without a calculator. Alright, so some review. A geometric sequence means there is a constant ratio between consecutive terms. So you are multiplying by something to get from one term to the next. The common ratio is the ratio between consecutive terms. So we're finding the ratio of any term divided by the previous term. It will be the same number. If it's not the same number, then the sequence is not geometric. All right, so if we look at this example, how would I find the ratio? Take any number, let's say 8, divided by the number before it. 8 divided by 4 is 2. 16 divided by the term before it, 16 divided by 8 is 2. 32 divided by the previous term is 2. 64 divided by the previous term, 32, is 2. So how would I find the next term? 64 times 2 would be 128, and so on. All right, so example 1 is find the common ratio. So take any term, let's say 10, divide by the previous term, and I would get 2. All right, if I started with 40 divided by the previous term, I would get 2. So the common ratio for A is 2. Common ratio for B, take any term divided by the previous term, right? Simplify this. What's negative 9 over 27? Well, that would be negative 1/3, right? Let's try it with negative 10 divided by the previous term. If I simplify, I still get negative 1/3. All right, does it work for decimals? Yeah, but again, this is where you're going to want your calculator just to make life easier. 4.5 divided by 3 is 1.5. If I did 10.125 divided by 6.75 on my calculator, I would again get 1.5. All right, example 2 says find the next 4 terms in the geometric sequence. So what's going to come next? I need 4 terms. First I want to find the ratio, right? Any term, start with 12. 12 divided by 36 is 1/3, right? 4 divided by 12 is 1/3. So how do I get from 4/3 to the next term? I'm going to take 4/3 and multiply by my common ratio. So my next term is 4/9. Multiply 4/9 by my common ratio, and I would get 4/27. Multiply 4/27 by my ratio, and I would get 4/81. Multiply 4/81 by my ratio, and I would get 4/243. All right, I'm going to do the same thing here. Find my common ratio. Negative 10 divided by 2 is negative 5. So negative 250 times negative 5 is positive 1,250. 1,250 times negative 5 is negative 6,250. See why you want a calculator here? Negative 6,250 times negative 5 is positive 31,250, and 31,250 times negative 5 is negative 156,250. All right, so in your book on page 706 is this formula here. It's called finding the nth term of a geometric sequence. So if we let a times n equal the nth term of a geometric sequence, then we can use this funny looking notation to find the nth term. So a is the first term of the sequence, and r is the common ratio. All right, you again are going to want a calculator for these. They are not fun. All right, so if we look at example 3a, the first term of a geometric sequence is 1/8, and the common ratio is 4. Can you find the 8th term of the sequence? So if we use the formula from the last page, a times r to the n minus 1, I want to find the 8th term. So the value of the 8th term is lowercase a stands for the first term. So the first term they told us is 1/8. And I'm going to multiply by, r stands for ratio. So 4 to the n, here's n, and here is n. So n is 8, right? 4 to the 8 minus 1. So the value of the 8th term is 1/8 times 4 to the 7th. The value of the 8th term is 1/8 times 16,384, which is 2,084. All right, let's try another one. Find the 5th term of the geometric sequence. So again, I'm going to find the value of the 5th term, and that's equal to the first term, -288, times the ratio. Well, this one didn't give me the ratio, so I have to find it. So I'm going to take 48 divided by -288, which is -1/6. So -288 times -1/6 to the 4th. This is -288 times 1 over, let's see, 6 to the 4th is 1,296. So plug that into your calculator and you should get, let's see, -288 over 1296 would end up reducing to -2/9, or the fractional equivalent. You can do it that way as well. All right, example C. Find the 12th term of this geometric sequence. So again, the value of the 12th term is the first term, which is 2, times the ratio. 4 divided by 2 is 2. So the ratio to the 12 minus 1. So 2 times 2 to the 11th is going to end up being 4,096. All right, use your calculator, figure out 2 to the 11th, and then multiply that by 2. All right, how about an ugly decimal one? All right, so the value of the 6th term is the first term times the ratio. So 16.1 divided by the previous term is 7, right? Again, you can do any of these. You could do 112.7 divided by 16.1, and you'd still get 7. So the ratio to the 6 minus 1 power. So 2.3 times 7 to the 5th. 7 to the 5th is, let's see, 2.3 times 16,807, which ends up being, this is a fun number, 38,656.1. All right, example 4. A ball is dropped from a height of 3 meters. The height of each bounce is 90% of the height of the previous bounce. What is the height of the ball after 7 bounces? Okay, so we have to think about how we would find our ratio in our first term here. So we dropped it from 3 meters, and the first bounce is going to be my 3 meters times the height is 90% of the height of the previous bounce. So 3 times 90%, which would be 2.7 meters. So if we think about that formula we've been using, the value of the 7th term is the first term times my ratio, which is 9/10. So, 0.9 to the 7 minus 1. So 2.7 times 0.9 to the 6th is 2.7 times, so times 0.531441, and so when I multiply that, I get 1.434897. So we can round that to about 1.43 meters after 7 bounces. All right, there are additional questions in your lesson practice. Check out pages 708 to 709 and let me know if you have any questions. See you later.